Hello everyone, this is Mr. Underkoffler. Today we're looking at the guided notes called Determining a Series of Transformations. Alright, follow along with me here as I read from the top of your page. A series of transformations refers to when a figure goes through two or more transformations. This could include translations, reflections, rotations, and dilations. Now, before I go any further, the textbook might say a sequence of transformations. When I've looked at Pennsylvania's item samplers from old PSSAs, I've seen the word series of transformations. So you can see this worded either way, either series of transformations or sequence of transformations. We're still referring to two or more transformations that maps one figure onto another. Okay, let's continue. Identifying transformations. Recall that translations, reflections, and rotations keep the image congruent, which means same size, to the original figure. However, dilations make the image smaller or larger than the original figure. When you have two figures, you can determine the transformations or series of transformations that maps one figure onto the other by analyzing the orientation, the relative position of the figures, and the size of the figures, whether they are congruent or not. Now, what I've done for you here is made a very nice box that kind of gives you a summary of the things to look for to know whether a translation occurred or whether a reflection occurred, whether a rotation occurred, or whether a dilation occurred. For translations, the shapes are still congruent. The orientation will be the same, which means, notice, they're facing the same way. So that's what a translation will do. A reflection also gives you congruent shapes, but the orientation is reversed. So notice the shapes are facing in opposite directions from each other, kind of like there's a mirror in between. Rotations, still congruent shapes, but the orientation has been turned. It's changed, but it's not reversed like with a reflection. So notice here, the shapes are facing in just totally different ways from each other. In fact, this one appears to be like a 90-degree rotation. Dilations, this is the only one of the four where the shapes are similar to each other, not congruent. So they're not the same size. But the orientation, kind of like with translations, will be the same. Now notice here, on the drawing I've given you, the shapes are different sizes, but they're still the exact same type of triangle here. The angles haven't changed, still the same type of triangle, it's just that one's bigger than the other. Okay, let's do, how about the first three problems? I've given you a total of 7 multiple choice problems, followed by 2 kind of open-ended problems. Let's do the first 3 together. Okay, problem number 1. Which series of transformations will map triangle ABC onto triangle A prime, B prime, C prime? So the first thing I always do is I try to see which one is the original, the one that does not have the primes, and then which one does have the primes. So that's what you got to look for right away. And then I start to think to myself, okay, what do I notice? Is the orientation the same? Is it different? Are they reversed? Or does it look like it's turned? And right away I can see this looks like they're mirror images of each other. So right away I'm thinking reflection, not rotation. Let me show you what I mean. Choice A says a 180-degree rotation about point C, followed by a translation. Now, right away I should think to myself, if I rotate this 180 degrees, this is what the orientation is going to look like. Clearly, that is not what this triangle, A prime, B prime, C prime, is looking like. So right away, I should be able to eliminate choice A from being a possible contender for the right answer. Gone, okay? I keep trying to cross that out, whatever. Gone. Is it choice B? Okay, a reflection across line AC, line segment AC. Well, that's this line here. If I reflect it across that line, it's going to look, it's going to look like this. Now, forgive me, the way I did this here with technology, now my letters are also reversed. Forgive me for that. But yes, A prime, B prime, C prime does appear to have that orientation. So what else does it say? A translation 3 units to the right and 2 units up. So let me use my highlighter here. 3 units to the right. Now, when I reverse this, when I reflect this, B is not going to be at the same place, but A and C will be at the same place. So let's just count from C to C prime and A to A prime. Is it 3 units right and 2 units up? Let's check that out. 3 to the right, 2 up. Yep, that puts me at C prime. 3 to the right, 2 up. Yep, so that does put me at A prime. Now, I know you might be like, well, not B prime. Well, remember, B prime is now going to be on the right side of the triangle. And actually, if I go 3 to the right and 2 up, yes, it would put me at B prime. So, ding, 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 ding. Choice B is our correct answer. If I could actually choose the correct pen here, I would go ahead and circle it. Now, let me go ahead and erase all this other stuff that I just did. Let me show you why choice C is not right. It says a reflection across line segment AC, which I already have here, and then a 90-degree counterclockwise rotation. So that would be like this, and yeah, that doesn't match my triangle, so definitely not right. Doesn't matter if I did keep the point of rotation as point B prime or point B. Wouldn't matter. It's not matching this triangle at all. So goodbye choice C. And choice D, oh, this one's tricky. A reflection over the line y equals x. That's kind of hard to picture. So I'm actually going to do work. I know. I already chose choice B. I know you're like, can't you move on to Underkoffler? Yeah, but sometimes we think wrong. And we think we did something right for B, but actually maybe D also works. So just bear with me here. I want to show you what I would recommend doing for your work. Anytime you have an answer choice that mentions a reflection over the line y equals x, I would go ahead and show a little bit of work on my paper. I would just pick one of the ordered pairs. It doesn't matter which one. I chose B because it was really close to the origin. Doesn't really matter who you pick. When you reflect it over the line y equals x, that is going to reverse the y and the x coordinates. Now, if I do a translation 5 units right, remember, you can show the work for translations by adding by an ordered pair. 5 units right means the x is 5. It didn't say up or down, so the y would stay 0. And if I would add that, that would put me at 7, 1. 7, 1, 1, 2, 3, 4, 5, 6, 7. That's here. Obviously, B prime is not at that spot. So, boom, choice D, I can eliminate it. But ladies and gentlemen, that's how you would show your work. Anytime you have a reflection over the line y equals x, you would reverse the coordinates, and then if it says the translation, you can then add by the coordinates of the translation. Okay, so number 1, done. Turn the page. Problem number 2. Let's do this one together. This one's a little bit different than problem number 1, so let's do it together. Which series of transformations maps FGHI onto F prime, G prime, H prime, I prime? Okay. Let's go through each one. Although, you can kind of look at the original figure here on the left, and this figure here, man, if you are familiar with rotations, you should probably already think that this is a 180-degree rotation. Look at how that makes the diagonal for HI the same as what I now have when I rotate it. Notice that that will make GF on the left side. So yeah, I'm already thinking this probably has to be choice D. But if you weren't able to recognize that, you can go through each of these choices along with me right now. Is it a reflection over the y-axis followed by a translation 1 unit down? Well, if I would reflect it over the y-axis, I'll go ahead and show that for you right now. That would put it here. Notice the diagonal for HI or IH is not the same. It's slanting a different way. So this is how I can eliminate choice A. And on your paper, you could have drawn a quick sketch And you could also draw it on scratch paper. In fact, I would recommend having like grid scratch paper with you. I guess line paper could work as well, but then you can draw quick sketches of what this would look like after you reflect it over the y-axis or over the x-axis for choice C, and so on and so on and so on. Okay, so where was I? Let's put it back the way it was. And forgive me, I should have eliminated choice A. Choice B, reflecting over the line y equals x. Remember what you do with this? You would change the coordinates of the y and the x. You flip-flop them. So let's just pick a random letter. Okay, write this down with me. G was -1 and 2. Left 1, up 2. If I reflect it over the line y equals x, that's going to make it G prime being 2, -1. And then it says the translation 2 units up. So I would add it by 0, 2, because 2 units up is a y of 2. It didn't say left or right, so the x would be 0. And what would that give me? 2 plus 0 is 2. -1 plus 2 is 1. So G prime would have to be at 2, 1. That would be here, not here. So goodbye, choice B. We just proved that it did not work for G to G prime. All right, is it choice C, a reflection over the x-axis? That would, let's go ahead and flip this guy. That's going to give me a different orientation, isn't it? That would make it look like this. Notice that HI is on the left and GF is on the right, and that's not the way that my prime's shape is. That's not the orientation of it. So choice C, I can automatically eliminate from being correct. All right, and as I mentioned way early in this entire part of going over this problem in the video, this really looked like a 180-degree rotation about the origin, which would actually put it, let's make sure we got this at the right place. So this used to be 2 units up, and now be 2 units down. And then if I go 3 units up, forgive me, I had this wrong. This should have been 2 units away from the x-axis. So that puts the G down here. And now if I go up 3 units, 1, 2, 3, yes, it would match. So there you go. I also could show work for this if this is hard to visualize. I could change the coordinates. So, for example, change the signs. That's what a 180-degree rotation will do. So instead of -1, 2, that's 1, -2. And then a translation 3 units up means I would add by 0, 3, and that would put G prime at 1, 1, and 1, 1. Yes, that is this dot right here for G prime. I should use my highlighter so you guys can watch me here on the screen. Yes, that is what I have, 1, 1 for G prime. And I could test that again for H prime and F prime and I prime, but this was pretty clear that choice D is the only choice that makes the orientation of the quadrilateral the way that you see it here for G prime, H prime, I prime, and F prime. So let's circle it. Choice D is the correct answer. Okay, problem number 3. I'll do this one with you. This is the last one that I'm going to do with you. You're going to do the rest on the rest of the multiple choice on your own. So, dilations. We can clearly see as we look at this original figure, X, Y, Z. This is the one that does not have the primes. This is so important that you recognize who has the primes, who does not. Who is the original figure, who is the image after the dilation. So the original figure is the smaller one, which on my screen is in blue. I think on your paper is just black and white. The primes on my screen is red. On your screen, again, it's probably a shade of gray. But this is the bigger figure. So think to yourself, what type of scale factor makes the original figure enlarge to become the dilation? It has to be a scale factor greater than 1. Because if you multiply by a fraction or decimal between 0 and 1, it would make the original figure shrink. And this one enlarged. So I can automatically eliminate choice A and B using that type of logic. So is it choice C or is it choice D? Now both of these have the same scale factor. So I can show a little bit of work here. So let's pencil in your hand, write this down with me. If I take X and I multiply its coordinates by 2.5, that's going to give me 2 times 2.5 is 5, negative 4 times 2.5 is negative 10. Now, which translation is going to put it where it actually ended up? Where did X prime end up? X prime is here. What are those coordinates? 1, 2, 3, 4 to the left. 1, 2, 3, 4 going down. So X prime should end up at negative 4, negative 4. Now, would that be a translation 6 units left and 3 units up? Or would it be 9 units left and 6 units up? Left means negative. 5 and negative 9 would give me negative 4. Negative 10 and positive 6, because going up is positive, would give me negative 4. So, boom, I just figured it out. It's a translation of 9 units left and 6 units up. If I did 6 units left, that would have put me at negative 1. And 3 units up would have put me at negative 7. So, that's the type of work that I can do to figure out if it's C or is it D. And there we go. We just figured out that it was D. And I think I actually have the work for Y to Y prime as well. Did I really have to do that extra work? Probably not, because I already figured out choice C did not work. But in case you're ever not sure, you could always do it for one more ordered pair and prove that that one works as well. Okay. Now that I've done 1, 2, and 3 for you, you're going to try 4, 5, 6, and 7 on your own. Now, you're not going to do 8 and 9 yet. We're going to save that for another day. But I would like for you to try 4, 5, 6, and 7 on your own. Hit pause on the video. Do 4, 5, 6, and 7. The last 4 multiple choice problems. And then hit play once you're ready to see how you did after you've done them on your own. Okay, have you already done 4, 5, 6, and 7? If you have not, hit pause now. Do these problems on your own. Okay, problem number 4. The answer was choice A. If you got it right, you can fast forward the video to where I go over problem number 5. If you did not get it right, then don't fast forward the video. Continue letting it play so you can hear me explain why it was choice A. For a reflection over the line y equals x, that's going to reverse the coordinates. So what used to be x will now be y, what used to be y will now be x. But then it said a translation 2 units to the left, which means adding by negative 2, 0. And that will give me negative 1, negative 2, which is where s prime is located. That will give me 3, negative 2. That's where t prime is located. And also that will give me, for r prime, negative 2, negative 4. And you can see here, that's where r prime is located. Now, if you thought it was choice B, let me show you why it's not. If I reflect this triangle 90 degrees clockwise about point S, where is point S? That's right about here. And then I go 1 to the right and 3 down. Yes, it does put S and T at the right place, but the triangle's orientation is not the way it needs to be. I would need a reflection about line ST, and that's not what I have here. So choice B, no good. If you thought it was choice C, if I do a 90-degree clockwise rotation about point S and then reflect it over the x-axis, ooh, that looks a little bit better. Why doesn't that work? Oh, actually, I have work to prove why this doesn't work. If I reflect it over the x-axis, then the y-coordinate would become its opposite. And so S would now be, let me get my pen, I'll show you. S prime would now be here. Or sorry, no, it wouldn't even be there. My bad. it would actually be here. And that's close, but not close enough. So I'll be honest with you. Choice C was the closest to being correct out of the wrong answer choices here. But it doesn't quite put the triangle exactly where it needs to be, even though the orientation would be perfect. And then if you thought it was choice D, if I do a reflection over the y-axis, let me put this triangle back to the way it was. And then, let me go ahead and do that. I'll flip it. Boom, looks like that. And then I do a 90-degree clockwise rotation. Yes, it does put the orientation the way I need it to be. But if I do it about the origin, then the R would still be on an axis. And this R prime is clearly not on an axis. So choice D was kind of close, not quite as close as choice C, but still not close enough. So choice A it is. That was a little tricky. All right, problem number 5. The correct answer was, let me get my answer key, flip my page, was choice C. If you got that right, you can fast forward the video to where I go over problem number 6. If you didn't get it right, then follow along as I explain why it's not A, why it's not B, and why it's not D. Okay, so the reason why it's not A, I can explain 2 different ways. First of all, if I rotate this 180 degrees, this should be the orientation. And clearly my primes, my image, is not that orientation. So that's reason number 1, it can't be choice A. The other reason is because the coordinates should go completely opposite. So instead of N being right and up 3, it would be left 1, down 3, and that's not where N prime is located. So 2 reasons why we can eliminate choice A. All right, why isn't it choice B? If I reflect it over the y-axis, that's going to make it look like this. And then if I do that by a 90-degree counterclockwise rotation, the orientation is like this. Notice where the diagonal is. It's not down here. So this is why choice B is no good. I'll go ahead and cross that out. And choice C. If I do a 90 degrees counterclockwise rotation, that would look like this. Oh, that is how this looks. But if I now reflect it over the x-axis, that's going to make it look like, if I can get it. Come on. Flip that up and down. There we go. Okay. That's going to make it look like this. Notice the diagonal is not exactly the way it should go. And that's why choice D is no good. By the way, it's easier to do with technology. When you're doing it by hand, you can do this kind of drawings on grid paper or maybe even on the graph that I've given you to help you to see if this puts things at the proper places. Okay, problem number 6. The answer choice was choice B. If you got it right, you can fast forward the video to problem number 7. If you did not get it right, then listen carefully how I explain this. First things first. You can look at what it says after the scale factors. Notice this has a 180 degree rotation. If I rotate this 180 degrees, that's going to look like this. And that's not the orientation of the enlarged quadrilateral. So choice A can be eliminated for that reason. If I reflect it over the x-axis, then it would, let me go ahead and do that, reflect up and down, it would look like this. And that's not the way the orientation is for my for my image. And then finally, if I do a 270 degree clockwise rotation, let's see, it'll be the same as 90 degrees counterclockwise, it makes it look like this. And again, the orientation is not correct. So that alone, if you focus on orientation, can help you eliminate choices A, C, and D. But here's the work for why choice B works. If I multiply by a scale factor of 3, here's A and B being multiplied by 3, and then when I reflect it over the y-axis, that's going to make it look like this, but obviously bigger. Or you can go ahead and realize that if you reflect it over the y-axis, it makes the x-coordinate change signs. So a prime, instead of being negative 6, 6, which is what happens after you multiply by a scale factor of 3, it's now 6, 6. And look, that's where a prime is located. Here I did it again for b prime. I multiply by 3, and then I change the x-coordinate from 3 to negative 3, and that puts b prime here at negative 3, 6, and that's where it's located. So there's the work that proves choice B is correct. And showing a little bit of work can go a long way sometimes. All right, problem number 7, the last of the multiple choice problems. The correct answer was choice C. If you got it right, you can end this video right now because we're going to do number 8 and 9 in a different video. If you got it wrong, please don't end the video. Listen to the explanation. First of all, here's the work that I would do to show you that choice C indeed works. I would take the coordinates and flip-flop them. And then I would go ahead and graph that. Seriously, I would graph that. And then I would think about what happens if I rotate it 90 degrees clockwise about point C prime. So if I go ahead and graph these new coordinates, let me make sure I get this right. C would be negative 2, 1. So that is, okay, it would be there. And now if I rotate this triangle 90 degrees clockwise about point C, make sure I get the point C correct, and there it is. It matches. There you go. There's your proof that choice C works. Now, I can also show you why choice A, B, and D do not work. If I reflect the original figure, which is down here, across the y-axis, that's going to make it flip like this. And then if I just translate it, it doesn't match. The orientation does not match. So that's why choice A doesn't work. Choice B, if I do a 180 degree rotation, that's going to make the orientation of the figure look like, well, not quite perfect there. Look like this, if I can get this straight. There we go. And then if I just translate it, well, the orientation doesn't match. So choice B, no good. And then finally, choice D. If I take the original figure and I rotate it 90 degrees counterclockwise, it would make it look like this. And then if I translate it, again, it doesn't match the orientation. So those are things you could have sketched on, oh, sorry, hit the wrong button. Those are things you could have sketched on your scratch paper or whatever you needed to see which way makes the orientation actually match. I will admit, choice C was the hardest problem on this entire packet of guided notes, and it's harder than what's going to show up on your review sheet and on your test. So if you got number 7 wrong, I would not lose sleep over it. All right, that concludes part 1 of the guided notes of determining a series of transformations. Thank you for watching. We'll see you next time.